It is the most important topic in algebra, and most of the questions in the competitive examinations are asked in complex numbers. A complex number is defined as an ordered pair xy of a real number if we denote the complex number z is equal to x plus iy. Then x is called a real part of the complex number and y is called imaginary part of the complex number. I again repeat, a complex number is defined as an ordered pair xy of a real number. If we denote the complex number z is equal to x plus iy, then x is called real part and y is called the imaginary part of the complex number. Now first we try to know that what is the meaning of the symbol I, iota. It is defined as a square root of minus 1. That is the solution of x square plus 1 is equal to 0. Then x square becomes minus 1. Then x becomes root of minus 1. This is defined as I. So I square is equal to minus 1. I cube is equal to I square into I. That is minus 1 into I. That becomes minus I. I to the power 4 is equal to I square to the power 2. That is minus 1 to the power 2. That becomes 1. Thus the value of I to the power n for n greater than 4 is I to the power r, where r is the remainder when n is divided by 4. Now if we raise 4 consecutive integer power on I and add them, then of the number will be 0. Now we raise 4 consecutive integral power on I, that is iota, and add them, then the sum will be 0. That is I to the power n plus I to the power n plus 1 plus I to the power n plus 2 plus I to the power n plus 3. That will become I to the power n. You take it common, 1 plus I square plus I to the power 3. That is I to the power n, 1 plus I square will become minus 1 and I to the power 3 will become minus I. So minus I will cancel out from I and minus 1 will cancel out from 1. So I to the power n into 0, that will become 0. Now let us discuss some problems based on iota. Illustration 1. Show that I to the power 19 plus 1 upon I to the power 25 whole to the power 2 is equal to minus 4. I to the power 19 can be written as I to the power 4 whole to the power 4 into I to the power 3. That is minus 1 to the power 4, that is I to the power 3, and it will become I cube. Further can be written as I square into I, and I square is written as minus 1 into I, then I to the power 19 will become minus I. Now if we write I to the power 25, it can be written as I to the power 4 whole to the power 6 into I. I to the power 4 is equal to 1 whole to the power 6 into I, that is I. Here I to the power 19, I to the power 19 will be written as I to the power 16 into I to the power 3. I to the power 16 can be written as I to the power 4 whole to the power 4 into I cube. I to the power 4 is equal to 1 to the power 4 into I square into I. That is 1 to the power 4. I square is minus 1 into I. That is minus I. Now, if we write I to the power 25, this can be written as I to the power 4 whole to the power 6 into I. I to the power 4 is equal to 1 to the power 6 into I. That will become I. So the problem will become minus I plus 1 by I whole to the power 2. You can write it I square plus 1 by I to the power 2. I square can be written as minus 1. So the numerator will become 2 upon I whole square. It will become 4 upon I square. So 4 upon I to the power I square is equal to 4 upon minus 1, that is minus 4. Let us come to the next example. Show that I to the power 17 minus 1 by I to the power 34 whole to the power 2 is equal to 2I. Now solution. I to the power 17 can be written as I to the power 16 into I. It will be equal to 1 to the power 4 into I. that will become I. And I to the power 34 can be written as I to the power 32 into I square. I to the power 32 can be written as I to the power 4 whole to the power 8 into I square. It will become plus 1 to the power 8 into I square is minus 1. So 1 to the power 8 into minus 1, that is minus 1. So the quantity in the bracket will become I plus 1 whole square. If we will open this bracket, that is I square plus 1 plus 2i. I square is equal to minus 1 plus 1 plus 2i. Minus 1 plus 1 cancels out, that will become 2i. So this is the answer. Now let us come to the third example. Evaluate 1 plus I square plus I to the power 4 plus I to the power 6 till I to the power 20. This question can be done by two methods. Method 1. In the question we have even powers of iota from 2 to 20. So the number of terms will become 10, 10. By including 1, the total number of terms are 11. Now, out of these 10 terms, 5 terms are having even powers of I square, and the rest 5 are having odd powers of I square. So these 5 terms cancel each other. So the first term, that is 1, is left. So the answer is 1. Method 2. Let us look at the second method. Sum is given as S is equal to 1 plus I square plus I to the power 4 plus I to the power 6 till I to the power 20. This forms a GP whose common ratio is I square. Now we know that the sum of GP A plus AR plus AR square till AR to the power n minus 1 is equal to AR to the power n minus 1 divided by R minus 1. Now the sum S is equal to 1 plus I square plus I to the power 4 till I to the power of 20. The sum can be written as 1 into I square to the power 11 minus 1 divided by I square minus 1. So this will become I to the power 22 minus 1 divided by I square minus 1. I to the power 22 can be written as I square minus 1 divided by I square minus 1. So this will cancel out, it will become 1. So you can also do this problem by a summation of the series, and the series is geometric progression. Let us come to a very important theorem, that is, if A and B are positive real number, then root of minus A into root of minus B is equal to root of, with minus sign, root of AB. Now we have root of minus A is equal to root of minus 1 into A. This thing can be written as root of minus 1 into root A, that will become I into root A. Root of minus B can be written as root of minus 1 into root of B, that is root of minus 1 into root of B, that is I into root of B. Now root minus A into root of minus B is equal to I root A into I root B, that is I square root AB, that is minus root AB.